question will be, what is the lead ionic equation for the reaction between iron chloride with sodium hydroxide? Expect your answers as a chemical reaction including phase. Okay, what is the lead ionic equation for part 2, magnesium sulfate and barium nitrate? Express your answer as a chemical reaction including phase. Okay, so from here we are going to look at double displacement reaction. Okay, so for this case, I believe the question just missing some of the important information because we don't know the state of iron chloride and also sodium hydroxide. And also same for magnesium sulfate and also barium nitrate. Okay, but I believe we all start with the solution. So let's look at the solution over here. We have iron chloride solution plus sodium hydroxide solution, and then we form iron hydroxide and also ammonium chloride. And then we can write a lead ionic equation by just write down all the ions, and also we know the lead ionic equation over here. Okay, so it looks a little bit complicated, but let's go through that step by step. Okay, first of all, we have iron chloride. It's in aqueous, and then we have a sodium hydroxide, and also it's aqueous. Alright, so I'm going to write it vertically because I'm running out of space. Okay, so for this reaction, we have a double displacement reaction. So we should be expecting the swap partner, and then we will have a sodium chloride. Alright, so the 2 should be outside of that. Okay, so the next step we're going to balance it. So we have 2 chloride, so we have 2 add 2 over here, so we have 2 in front of sodium hydroxide. Okay, so the chemical reaction is balanced, however we're missing the phase. Okay, so for this case we have double displacement reaction, and we likely have a precipitation reaction. So we're going back to our solubility table. We should be able to conclude that our sodium chloride must be aqueous, because sodium ion and chloride ion, when they form some chloride in aqueous solution, some chloride is highest soluble in water. So that's why it must be aqueous. So the other ion another compound that form is the interaction between iron and hydroxide ion. Again, when we are going to look at our solubility table, we should be able to find that iron hydroxide is not soluble. It's, I would say, slightly soluble. So that's why we should have a solid being formed over here. Okay, so we have a completely full reaction equation over here, and we have to write the lead ionic equation. Alright, so for lead ionic equation, you can do 2 different things. First of all, you can just write down all of the ion on the left like that, just like that. Doesn't matter. You can write everything look like that, and then you're going to remove the ion that you can see on the left, on the right. You can cancel it out, and then you will have the lead ionic equation. This is completely fine. There's no problem. Completely fine. But another easiest way, I would say faster way that you can do is that when you know the actual reaction, what species is actually reacting, you can just show those ions and then the final product, and this will be the lead ionic equation. Okay, so from this case, we know that the sodium chloride is just aqueous solution. They are in it's still soluble. They are sodium ion and also chloride ion, so they just spectator ion. So we don't have to include that in the lead ionic equation. And also we know that it's iron 2 react with hydroxide ion to form iron 2 hydroxide. So we only have to show the ion that actually in the reaction, that actually take part in the reaction, and then we just show it, and then this will be the lead ionic equation. So and then we will have a solid. Alright, so exactly the same on the left. Either way will be correct. It's up to you. Pick one of it. Okay, so another example will be magnesium sulfate with barium nitrate, and then it will form magnesium sulfate. We should start with an aqueous solution with barium nitrate, aqueous, and then they will going to form magnesium nitrate and also barium sulfate. Okay, again, balance the chemical reaction, and yeah, they're balanced. Okay, so we have to keep the phase to each of the products. So this should be aqueous, again referring to our solubility table. Nitrate salt, they are always soluble. But for sulfate salt, when they combine, or sulfate, when combined barium ion, they will form a salt, they are insoluble. Okay, so from here, yeah, we know that is just the sulfate ion we add with the barium ion to form sulfate ion. So we have barium ion. We first start with barium ion from barium nitrate with our sulfate ion, again from magnesium sulfate, and it will form barium sulfate. And this is the ionic equation. Exactly the same procedure to solve it when compared to part 1. And you can again, you can also express the whole equation in individual ion and then cancel out the spectator ion. You will still have the same net ionic equation. But personally, if I understand what the reaction actually going on, I will only show the ion that's actually reacting, and they will be. I don't have to waste a lot of time to just weigh out all of the ion and then just remove the spectator ion. Okay, so the solution is correct.